Adam, and thank you everyone for being here. So I'm going to talk to you about this thing called cloud automation. And this is kind of like an ambiguous term, but we'll make it more clear. So because I'm not over Star Wars, and I don't know if anyone really gets over Star Wars, cloud automation to me is just the ability to use the force. Like, we're already programmers. We write software for a living, and I mean, to most people, that's magic. So how do we take this magic that we already do and kind of take it to the next level? Really get in touch with the universe that we live in. So cloud automation. Like, what am I actually talking about here? The way I like to describe it is, how do we build a self-healing cloud? How do we build a system that is intelligent enough to know when things happen and is able to fix them? All right, so first, who am I? I'm Jarrett Cruger, and I automate the cloud at Nojitsu. And if you want to find me on the internet, I'm Jay Krugs on the internet. So for those of you who don't know Nojitsu, we run a platform as a service, or as we like to describe, we execute untrusted JavaScript in the cloud on arbitrary servers that we run. And if you've never done this before, this is at the root of some of my favorite vocabulary. And we do this using a system composed of microservices. And I want to get into this vocabulary that I will be using quite often. So, slide. All right. So both of these terms, determinism, when computers act and do what I tell them to do, and I can depend on them giving me consistent answers. And then non-determinism, when we start entering this quantum universe and things just start misbehaving, where at different points in time I'm starting to get different answers and I have no idea what's happening. And this is super aggravating, but I think it's something that we're going to have to embrace going forward. So, ScienceCat is here to tell us that we're talking about cloud automation for microservices. So, what are microservices? Can I get a show of hands? How many people have either run with a system of microservices or have heard of it? Okay, cool. So, for those of you who haven't, microservices are a different way of composing our application, where in the past we would have this monolithic web service, typically run in Java. We'd ship this huge war file that has code that is very much interconnected and coupled. And that's kind of like what this picture is. These arrows represent that hard coupling programmatically. And microservices changes this, and we kind of split out those different pieces that would normally be very much coupled together in a single program, and we make them separate web services. So it turns this hard coupling into a looser coupling. So instead of interacting programmatically in one web service, we now have multiple web services that are interacting over predefined interfaces over the network. And this is important when we talk about scaling. So, all right, let's look at the initial example, a monolithic web service. How do we scale this? If we get to a certain load threshold, what do? All we can do is replicate the entire thing over and over again. And while this is fine, it's terribly inefficient, and it doesn't really give us an idea of what part of our system needs to scale. What part is actually being used the most? Because we're just kind of wasting hardware money by just throwing one huge application well, no, more servers, and it continues. So with microservices, now we can actually do this more intelligently. So when you have each pieces of your system separated, you can scale each one at a time. So in this diagram, let's think of the blue square as a queue service and the green triangle as your front-end application. If your queue service is getting more load, you can now bring up another piece of that, assuming it's architected to handle multiple servers, but you're able to scale that more intelligently. And say this orange little chat thing is your chat service that's dispatching all the messages. You can scale each of these pieces individually, and that's super helpful. Okay. So when it comes down to microservices, it can actually become really fun writing them, but we shouldn't really get carried away. So the Unix philosophy is actually very much influenced the concept of microservices. And for those of you who don't know the Unix philosophy, it's do one thing and do one thing well. And it's very much around this concept of modularity and reusability, which, having used Node, you guys should be familiar with. They're very much the same concepts. And just to go nerd out a little bit on the Unix philosophy, streams are like my favorite thing. And like they were the ones that popularized this. And it's super simple interfaces where you now have these separate programs, and we can scale this to microservices that now interact with each other in that same kind of way. And just to throw you a quote here, Doug McElroy was who pioneered streams in Unix, and he says, "We should have some ways of connecting programs like Gart knows. Screw in another segment when it becomes necessary to massage data in another way. This is the way I have I/O also." So I like to think about this in microservices. We're able to plug in other services kind of in the pipe chain, per se. And this is actually very much possible in Node, where we do have this ability to pipe and create these. This would be an example of a duplex stream. So Node and microservices. As I'm kind of alluding to, they are very much kind of from the same background. They're from the same concept. And so they kind of go hand in hand. See, microservices love Node.js. So Martin Fowler actually pioneered microservices at Netflix. And he talks about this concept of products and not projects. And some of the argument that he makes is that now the developers are able to own a product, and that would be like a web service, and they kind of manage that over the course of the lifetime. And why I think that matters is Node modules has the same kind of concept, where we build these small little pieces of our application and segment them out because it gives that sense of ownership. We're able to now decouple our, just how we write software and how we write software services. So a module is kind of a microservice. I like to think of them as all the same thing. It's kind of modules all the way down. Instead of turtles, it's modules. And the thing that I love about Node and why I really like streams is API simplicity. When I came to Node, I had no idea what TCP was. Using HTTP made sense, but Node made this approachable for me. I was able to read the documentation and kind of funge my way through the code, and I was like, oh, okay. It just has this write method. We have this socket representation in TCP, and you can write data to that socket. Like, okay, that's something that I was able to figure out through reading code on GitHub, and that was super powerful for me. So microservices aren't perfect. I don't think anything is. We like to think that there is a silver bullet, but there never is. So better availability. Do we actually get this with microservices? It's not really determined. You can argue you get better availability, but now you have to deal with partial outages and be able to handle those different kinds of edge cases. It's now not just a single application, which is helpful in some ways, but you have to be more careful. Easier scaling. I kind of went through that scaling example, and it makes it super simple to scale pieces of your application, but it's not necessarily easier. You just have to know more about your system, which I think has value, but again, that doesn't make it necessarily easier. And eliminate single points of failure. Well, that's actually one of the first problems is instead of having one single point of failure now you have an n number of single points of failure. Now there's more moving parts in your system. So with this, we're going to get to one of my favorite words. You have more moving parts, increased surface area of failure, the math around this gets a little complex, and now we run into this non-deterministic idea. But it's okay. Everything has trade-offs, and even though we are making some things more complicated by using microservices, nothing's perfect, and we'll get to a better place. But okay, I know I've been droning on about microservices, so why should you use them? I'm telling you this thing, it's super complicated. Why should we be using microservices? Why are we using microservices? And it's kind of because I said so, but there's more things to it. So when things go wrong, so I'm going to explain to you the worst case scenario when using microservices. So what happens when a service goes down? Okay, one of the queue services just went down. Okay, that's fine. We have another one. We should be okay. But that other queue service couldn't handle the load. So, we might be in trouble now. Now the front end service goes down. Okay, users aren't getting to our application. Now we have multiple product teams that are managing their services. Nobody knows whose fault it is, what's happening. PagerDuty is making money, and people aren't happy about getting calls. And now the chat services starts going down. Okay. This is the one tricky part about dealing with microservices, and especially when the ownership is over the service, because you still need greater insight into what's happening. And yeah, nobody likes getting these calls. But it's okay. We have this concept called monitoring. This is kind of our savior in a world of microservices. This is where we find out how everything is operating, because now it's split into all these various services. So the first step is collect metrics, all of the metrics. I don't care what your application is doing. Let's start getting some insight, and it's all in the data. So what are some examples of metrics that we should start collecting? The most basic is logs. And specifically, structured logs are super useful, because if you're now sending JSON logs into a metric system, you can kind of parse those, and if you're composing them in a stricter fashion, you'll be able to take action purely off what these logs are telling you. Memory. Since we're dealing with Node, memory is actually the biggest, thing to worry about, because we're dealing with mostly I/O, and taking data from one service into another. If we're buffering some of that data because we're doing some operations, or we need to assess it in bulk, we need to pay attention to how much memory we're using. Memory leaks are a thing, and this is something that you should definitely be aware of. And requests. Requests are useful because it's actually the simplest mechanism to see how much load your application's getting. This is actually what Netflix uses to do their smart scaling, is simply requests, because you can do a lot more complex algorithms, but at the end of the day, requests are the most reliable source to go through. So now that we have this data, what are we going to do with it? We're throwing it at the system. We need to do something with it. And let's look at the data. And so how do we do that? The first thing is store it somewhere. Whether it's in a database, a file, it doesn't really matter. Depending on the scale of your architecture, if you can just write files of some kind of metrics and then reprocess them later with a cron or something, that will give you that first step of insight into what's happening. Graphs. Graphs are the most amazing thing to use, because you can look at numbers in files, but it's mostly just going to be useless. You want to actually see something visually. We're more visually engaged as human beings, so you should be able to take that data and just put it in graph somewhere so you can see the trends. And then from those trends, you can start bridging correlations to, maybe some of your services have been going down, you're not sure why. Using this data will help bridge those relations. And Lisa Simpson is really, really good about making graphs. And this is kind of what we run into when we're facing all these problems, is that as we learn more about our system, we become less happy because things are complicated. And this is the quote: "As intelligence goes up, happiness goes down. See, I made a graph. I make lots of graphs." But it's okay. Like, what I learned in yoga is that living in the now is actually way more important, and being present. And in this context, living in the now means to act now. So we can take action on, as we're getting this data and kind of getting an understanding of it, we might not be sure, but we can begin to take action as, those light bulbs start ringing. So, what kind of action can we actually take? So, fix something. So in this little setup, we've had these apps that are just sending data to the metrics cluster. These could be just different parts of, your overall architecture. And now we have these action services. These action services are just another set of microservices that, are set to perform a particular role. And fixing something is, curating a fix that you've established will recover from a problem. One of your services starts running out of memory, and, just restart it, like whatever. You gotta start somewhere if you want to, be able to find the root cause. Scale up or scale down. This is where you can start, playing with the more fun things of having this kind of system set up, is being able to intelligently scale your system as you start getting more requests. Netflix uses these, they have some predictive algorithms that kind of guesses how much load they're getting. That's because they're just getting ridiculous load in general. But you can start simple and start figuring out what thresholds you might need another server at. And whether this starts like a manual process, it doesn't matter. You're gaining more insight into how your system works. Remove a server from the pool. This is probably the most crucial and simplest to start out with. If something goes down, I think we've learned that we can't depend on the infrastructure providers that we have. If there's a bug, a security bug, Amazon's going to restart all the servers. And that's going to be super painful. And while you might not be able to automatically recover if you're just running on Amazon, if only certain servers go down during this, having the ability to remove those servers from the pool and still somewhat operate is a starting point. Okay, so I want to tell you a little story about my own experience at Nojitsu. So I made what's called an SSH Micro-service. So as I mentioned, at Nojitsu, we run just other people's applications in our cloud infrastructure and watch them and monitor them and make sure that they stay up. And many of our users, they might be new to Node, they might not know what they're, exactly what they're doing yet, but they're trying, and a lot of them just build products. But a lot of times you run into applications that can have a memory leak or just start acting in a non-deterministic manner. So to handle these cases, I crafted this SSH service. So as you can see in the picture here, we have a load balancer. This load balancer detects when we start getting econ refused, when we stop being able to proxy to an application. So when this starts happening, we then tell our metrics cluster, oh, this is happening. Just start sending messages that this application is now down. And this then relays it to the SSH microservice and executes a finely crafted SSH command that I figured out works and will recover from this issue. This allows those applications to automatically be fixed, and as I start collecting more data on whose applications are going down, we actually have a good way to start dialogue with these customers that, okay, your application keeps going down. How can we figure out what's happening? So for the solution, it was all in the simplicity. I identified the problem. I was able to craft a solution for this problem. And I just kind of put the pieces together. And it might not be a perfect solution, but it worked. And this is kind of what the monitoring system was telling me. And that's why I kind of had to fix this. So the problem here is that even, we're talking about building this more fault-tolerant cloud, this self-healing cloud. How do I start making steps towards that? Being able to fix people's applications and fix other services in our architecture is a good start, but what if this SSH service goes down? right now it's only a single server because that's all that's needed, but if I want this to scale over time and be more resilient, it needs to be distributed. So even with simplicity, it lacks the flexibility that we need in order to really move towards this future. It has no built-in fault tolerance, and it uses a local queue. So even if it somehow was taking enough HTTP load to warrant another server, this actually just wouldn't work. But it's still all fixable. So this is a concept of distributed systems. And I don't know if you've tried to read any white papers, but shit is complex. Like, you don't know how they work. But, all right, let's take a stab at this. How would I make this distributed? All right, we can add a more couple servers to the pool, and let's make them communicate with each other. But how would we do that? So there's a particular protocol called Raft. Let's use that, and I'll go into what Raft is in a minute. But it allows this service to, if one of them fails over, it guarantees that that service will still be consistent. It will still have the same state across all nodes. And this allows each one to have its own local queue, because that is then automatically replicated. And so if I want to go implement this, I would have to use a working module or implement one myself. And unfortunately, in the Node ecosystem right now, there's 3 Raft-like modules, but none of them are actually complete. So I've actually been talking with one of my coworkers on how we could make one that would work. And I encourage you to read the white paper and test, because that's the only way you really understand how this protocol works. Because we've had people tell us, these academics tell us that, yes, this stuff is proven, but we're programmers. We like to do things. And how do we know that this theory that they're telling us is just going to work? So what is Raft? Raft is a protocol that allows distributed consensus to exist. Consensus being all of the nodes agreeing on a single state of determinism. So it is a consensus algorithm. And log replication is the first piece of it. So each time you say I need to SSH into a machine, I would then tell one of the nodes, which is the leader, that this needs to happen. The leader will be like, okay, it will replicate that state to all the other servers, and once it gets a message back from those servers, it's then able to execute that task. So this ensures that the entire system is on the same page. And there are 3 different states that any of these machines can be in Raft. And as I mentioned, there's a leader. That's the authority in the setup. And then there are followers. And the only time that a candidate comes to be is if the followers no longer are receiving messages from a leader. And then they have what's called an election. So in the case of a failover, an election occurs, one of the new followers will become the new leader, and the system will keep on operating. So I talked about reading white papers, and as I mentioned, this stuff is difficult. You sit down and try and read one. If you read it once and you understand it, great, but you will most likely have to read it multiple times. So the argument I'm making here is we should all be reading white papers. Even if we don't think it directly applies to what we're doing, if we want to evolve and keep moving forward as programmers, the entire industry of anything is all going to be based on software in the future. We need to understand how distributed systems work. We need to be able to make things fault tolerant. So we should understand what these academics are talking about. And yes, as I mentioned, this is hard. This is not easy to do. But if we all start reading them, we can talk to each other. We can communicate. That is the power of collaboration that GitHub has provided. We can also do this with papers. Other people gain their own insights from what they're reading, and being able to cross-examine and pass along that information is super valuable. And reading just once is the beginning. This guy, Michael Bernstein, wrote a blog post recently that kind of fascinated me. And he's talking about why like, should you read white papers? Kind of the same concept. And he describes it as, when you pick up a white paper, it's a relationship. Like, it's something that you're going to like pick up, put down, and come back to again and again, because it's a process to actually understand that, and it's okay. And consider it like stretching. Like, if we want to evolve and continue expanding as programmers, like, sometimes we have to stretch. If we want to build more complicated things, it's totally intimidating, but hey, it's going to happen at some point. And yes, I understand this is all overwhelming. I'm telling you all to go read white papers, and I didn't even graduate from college, so those things are hard. But relax. It's all about starting simple. Starting with a small little component that solves a problem in whatever system you're working on. And this brings me back to kind of the basics. It goes back to modules. We build these small little composable pieces. So let's take the same approach with these more complex systems that we're going to be developing. We build a piece and we start putting more together until it can work as a distributed system, because everything's in stages. So now I have a little demo for you guys. And first I want to explain the architecture of this demo. So one piece is this edge proxy. So think about this as just a load balancer. It has one application it's sending requests to, and it's just doing round robin load balancing. Nothing too special. And each one of these applications is talking to a metrics cluster, or in this case, just a single metrics monitoring process. And if any particular thresholds that or the intelligence that I've put into this metrics cluster, if it hits any of the thresholds that I've set, it will then send an action to be taken on this distributor. And the example I'm showing you is just add removing apps from the pool. So if one goes down, we can now just automatically take that out of the pool and keep distributing requests. And if any of you who want to take a look at the code, it's all open source. You can find it on my GitHub. And all right, let me show you this. Okay. So right here, I'm starting the distributor process. This is what's going to be sending messages to only the single proxy in this case, but it could be n number of proxies. So, and then I'm going to start the monitoring process. This is going to be assessing that data that the apps are sending it, and also going to start the proxy here. So now, let me start up a couple applications. I'll start one on port 8081 and one on port 8080. And I'm going to copy one of these process IDs, and let's start curling the proxy. The proxy is at port 3000, and if all you can see that, you can see it's just round robin load balancing to these two machines that I started up. So that's all fine and dandy. But what if I decide to kill one of these processes? Uh-oh. All right, let's keep curling. Uh-oh, we got one econ refused. All right, now we're back to normal. And now it's just only hitting that one machine. So what happened behind the scenes here is that I'm just gathering uptime information from these applications. Just something super naive to see, like, when is it up? Is it not up? Now let me start this application back. All right, so now I'm back to proxying to both nodes. Because on startup, it was then able to send a message that then informed the proxy to add it back to the pool. So now we can go back to operating on all these machines. And so this is the concept I want to reinforce. We can build little simple setups like this. And that's the beginning to building this self-healing cloud, this dream that I envisioned before I even understood what I'm doing now. Like, this is some notion that I've been holding on to, and I do believe it's possible. And that's it. I'm Jarrett Cruger. That's me on the internet. We can talk later tonight. Thank you.